Welcome back to The Explainer. Today, we are talking about surviving the absolute worst-case scenarios in IT. I'm talking massive hardware meltdowns, totally unexpected power outages, and those unpredictable natural disasters that literally give IT admins sleepless nights. When the stakes are that high, just hoping for the best, yeah, that simply isn't a strategy. You need a rock-solid plan to keep your business running. Okay, let's dive into this. At the very core of our mission here are disaster recovery and business continuity. Now, I know those can sound like basic corporate buzzwords, but they are actually your lifeline. This is all about keeping the lights on when your hardware, the power grid, or even nature itself turns against you. It's the absolutely vital practice of minimizing downtime so that when the unexpected strikes, your data center can restore normal operations before your customers even notice a hiccup. All right, here's our roadmap for today. First, stopping downtime with HA and FT. Second, automating recovery with SRM. Third, the return to normal. And finally, advanced strategies and cloud DR. Let's get right into it. Section 1, stopping downtime using HA and FT. Our first line of defense is proactive high availability, and the absolute keyword here is proactive. Think of proactive HA as your early warning system. By tapping into hardware health monitoring using vSphere APIs, it can actually detect when an ESXi host is getting sick, way before it crashes. It then works directly with DRS, your load balancer, to preemptively evacuate your virtual machines over to healthy hosts. It's basically moving your workloads out of a burning building before the smoke alarms even go off, preventing service disruptions entirely. But what happens when a failure is just instantaneous? Well, there is a crucial distinction to make here, especially if you are studying for your certifications. High availability acts kind of like a quick EMT. If a host suddenly dies, HA automatically restarts those VMs on a healthy host, with only a very brief moment of downtime. Fault tolerance, however, is completely different. FT creates a perfectly synchronized twin of your VM on another host, running in exact real-time lockstep. If the primary host dies, the secondary takes over instantly. We are talking zero downtime and zero data loss. Now, for any of this to actually work, you need spare room, right? That's where admission control steps in. Admission control is essentially the bouncer at the club. It strictly maintains your N+1 redundancy, meaning you always have at least one completely empty backup host ready to go. It literally prevents you from powering on new virtual machines if doing so would eat into your reserved emergency space. It forces you to keep that capacity available so your mission-critical workloads always have a safe place to land during a crisis. Moving on to Section 2. Automating recovery with SRM. So what if you lose the whole club? What if an entire data center just goes dark? That escalates us to site-wide disasters, where we really need to bring in the heavy hitters to automate recovery. Enter VMware Site Recovery Manager, or SRM. And this brilliantly illustrates how you handle a true crisis. You remove the human element. Because, let's face it, when disaster strikes, people panic. And that is exactly when the wrong cables get unplugged. SRM replaces that panic with a pre-written playbook called a recovery plan, which defines the precise boot order of your critical VMs. It completely automates the failover process to your secondary site. And honestly, the best part? It allows for non-disruptive recovery testing. That means you can simulate a total meltdown on a random Tuesday afternoon without affecting your production users, proving your plan actually works. As you configure SRM, you must choose between two distinct paths. First, a planned migration. This is moving on your own terms. Say you see a massive storm on the radar. You gracefully shut down, move the data, and spin back up with zero data loss. A disaster recovery failover, on the other hand, is hitting the panic button after the power has already been cut. It's for unexpected failures where you probably will experience some data loss based on your RPO, your recovery point objective. Understanding this difference is super vital for setting expectations with your business leaders. To make SRM actually work, you need to get your data from Site A to Site B. vSphere Replication is the transport layer doing all that heavy lifting. Because it's hypervisor-based, it really doesn't care what kind of storage you have underneath. vSAN, VMFS, NFS, it handles it all. It gives you granular per VM control. This is incredibly important because it provides a highly cost-effective disaster recovery alternative for small and medium businesses who might not have the massive budget for expensive hardware-based SAN replication. Section 3. The return to normal. Let's see how this builds because, hey, surviving the crash isn't the end of the job. Eventually, the smoke clears, the primary data center comes back online, and you need to go home. Completing the SRM recovery loop is a three-step process. You start with Step 1, automated failover to your secondary site. When the dust finally settles, you need Step 2, reprotect. This reverses the replication flow. It takes the changes you've made while running at the backup site and syncs them back to your newly repaired original site. Once those sites are identical again, you execute step 3, failback, smoothly moving your workloads back home to resume normal operations. And finally, Section 4, Advanced Strategies in Cloud DR. Everything we've discussed so far assumes you actually own a fully equipped secondary data center. But I want to pose this question directly to you. What if you don't? What if your business doesn't have the real estate, the hardware budget, or the IT staff to maintain a secondary idle data center that just sits there waiting for a disaster? Well, the answer to that is VMware Cloud Disaster Recovery, or VCDR. This is disaster recovery as a service. Instead of buying a whole second building, you protect your on-premise workloads by failing them over directly into VMware Cloud on AWS. This drastically lowers your capital expenses. Plus, it leverages cloud storage tiering to optimize recovery times, giving you the power of a massive secondary data center, strictly on demand, exactly when you need it most. Now, as we plan these strategies, we constantly have to balance cost versus speed. We often confuse backup and replication, but they serve entirely different masters. Backups are for your long-term archiving and ransomware protection. They are cheap on storage, but your recovery time objective, or RTO, is going to be slow because you have to unpack massive files. Replication, which we focused heavily on today, is for mission-critical availability. It consumes way more storage to maintain those live continuous syncs, but your recovery time is blindingly fast. Bottom line, you need both to survive. And to build out that backup side of the equation, VMware natively integrates with some truly incredible third-party solutions. We're talking providers like Veeam, Rubrik, Cohesivity, and Commvault. They plug right into vSphere and bring advanced features like deduplication to save you storage space, compression, and instant VM restores, fully supporting both your on-premise and your new hybrid cloud strategies. Which leaves us with one final thought to wrap up today's explainer. Look at your own environment right now and ask yourself, are your mission-critical applications truly resilient enough to survive a total site failure with zero data loss? Do you have HA handling the small hiccups, FTE protecting the critical servers, and SRM or VCDR ready to automate the absolute worst-case scenario? Take these concepts, go audit your infrastructure, and make sure your business is ready for anything. Thanks for learning with me today, and I'll catch you in the next explainer.